So now we continue with question number 16. We have a triangle with 3 sides given, and we are to find the area of the triangle. To do that, we're going to use Heron's formula. First, we just need to find the semi-perimeter, the 3 sides, and dividing by 2. Once we know the semi-perimeter, we're going to then replace it into this formula here for S. So, in our particular problem, we have that the sides are 32, 17, and 37. So when we add together 32, 17, and 37, we end up with 86. And so once we know that the perimeter is 86, we then divide by 2. Oops, not that part. And we end up with 43. So now as we input all of our values into the square root, every time we see an S, we're going to type in 43. So we're going to have the square root with parentheses. We're going to have a 43, and then we're going to have another set of parentheses, another set of parentheses, and another set of parentheses. And to each of these parentheses, we're going to have 43 minus, 43 minus, 43 minus. And then we need to enter the side lengths of the triangles, triangle A, B, and C. So we go back here and we look at the triangle, and it is 32, 17, and 37. And now we finally get our result, 271.64. Here it says round to 4 decimal places. Sorry, so it would be 271.6395. This 4 rounds up to a 5. So that's question 16 for you. Now for question 17, we're going to use a different formula because here we have a side angle side. Let's start by considering what the triangle would look like. A triangle would look like 2 sides that are given are 18 and 22. And then we have an included angle of 54 degrees. The included angle is the angle in between those 2 sides. And then we don't know what this other side is, but we don't need it because we can use the area is equal to 1/2 AB sine C formula, where A and B are the side lengths that we actually know. And then C, capital C, is going to be the included angle. So for our particular problem, that means that when we fill in this formula, we end up with area is equal to 1/2 22, 18 sine 54. So now we can go ahead and type those numbers into the calculator. And then that would result in 160.1854. So going back here, we have round to the 10th place. And so that would be 160.2 with the 1 rounding up to a 2. Now for question number 18, this is the law of sines problem, and I went over this in great detail in my review lecture for test 3. So what I'm going to do is I'm going to actually pull that video up for you. Alright, so here we have pulled up on YouTube question number 3 from the lecture 22 review. You can see I listen to a lot of Harry Potter. Anyway, what YouTube is suggesting for me to watch, and other exciting trig lectures. Here we have question number 3 is found at 254 in the trig lecture 22, which is review for test 3. So you can go ahead and pull that up so that you can watch that. I would play it right here for you, but it would make this video a lot longer. Also, part of the screen is going to get cut off, but you're going to look for it starting at 254. Number 3, we are looking at the ambiguous case using law of sines, so we need to find both scenarios of the triangle, and I'll do this one on the whiteboard. So for this problem, the first thing you want to do is so to see the rest of this lecture, just go on over to lecture 22 review for test 3, and you'll be able to see the rest of this problem, which is great because then I already went through it very thoroughly in that lecture, and so that would be question 18. Now for this next problem, we're going to be looking at question number 19, and that is a triangle where we know all three sides and we just need to find the included angle. Now this problem is also explained in that same video lecture, so you can go back to that video lecture, and starting at 21:49 I will be going over. Now we're moving on to question number 6. Question 6. I'll zoom in here. So what we have are three known sides of a triangle but an unknown angle A. So you can watch the rest of that lecture right there according to your needs to review that concept. And then here we have question 20. We're looking for the component form of vector V, knowing the magnitude of the vector and the angle it makes with the positive x-axis. And that same problem is question number 9 from this lecture 22 review video. So here I review that same concept. Question number 9. Find the component form of the vector V. If the magnitude of vector V is 3, and when drawn in standard position lies in quadrant 3, and makes a 60-degree angle with the negative x-axis. So an explanation for that same video then, for that same problem is right there. And then for the next question, question number 21, here we have the component vectors in the I and j form, and we are magnitude and the direction angle of this vector. And you can actually see that it's the following problem right there on that same lecture. So these two problems from the final exam are back to back in this lecture. Again, remember that as you work through this particular version of the final exam part 1 that I am posting here, all of these problems are in order, whereas the problems on the final exam will be shuffled. Okay, to do this next question where we're adding graphically, so what we want to do is start by graphing u at -3, 1. So we're going to start by placing our initial point at the origin, and then we go 3 back and then 1 up. For the second vector, you can either start it at the origin again, or you can start it at this point. Either way, it wouldn't matter. So if you were to do -1, 2, and you would start at the origin, then you would go -1 over and 2 up. But you could alternatively start at -3, 1, and then go 1 back and 2 up. And you can see then you have the two sides of the parallelogram. And also you could also put u likewise right here. So you could start u here. When you do graph this, you don't want to graph the full parallelogram. You just want to either choose for both vectors to be centered at the origin, or for one of the vectors to start at the origin and then the other one pick up where the other one left off. So in the end, you'll end up with a total of 3 vectors. So you will want to clear some of these. So I'm keeping the ones that start at 0, 0. And then for the u plus v vector, you add the x, which is -3 and -1, the x components, which would give you -4. And then you add the y components 1 and 2, which gives you 3. And you can see then that this resultant vector is the diagonal of that parallelogram that we had drawn earlier. Alright, and that is the very last problem for part 1 of the final exam. So utilize that video back here. This again is lecture 22, and you can find that on Blackboard. Go to Unit 5, Applications of Trigonometry, scroll down to where it says lecture 22, review for test 3, and you just click right there, and it will open right up for you. Okay. So the next video I will post, I will go over the problems on the final exam that require you to show work.